All right, hello everyone, and welcome back. We're now in the 505.3 manual. Now that we're into the middle of the week, we're going to focus on specific topics for PowerShell, and in particular, what's coming up in the next manual, we're going to discuss WMI, the Windows Management Instrumentation service, the scripting of local accounts like the local admin account, including the management of its password, and Active Directory scripting. So today we're going to talk about, for example, how to create a scheduled task that runs a PowerShell script to manage the passwords of local accounts in the administrators group. And for example, the recommendation is going to be don't use Microsoft Laps. Now, if the choice is between doing nothing and using Microsoft Laps, then of course use Microsoft Laps, but we're going to look at a PowerShell solution that is better. All right, let's take a look at what's coming up for today's agenda exactly. The first section is on Windows Management Instrumentation. This is a service that's installed and running by default on all Windows machines, and PowerShell is deeply integrated into it. Section number 2, PowerShell scripting for local users and local groups. So the distinction is local users are defined in the registry of each server and workstation as opposed to domain users that are in Active Directory. And of course, local groups includes the all-powerful administrators local group. Now, what about domain accounts and global groups? That's section number 3, PowerShell for Active Directory. And section number 4 is related to this. We're going to see that every object, in fact, every property of every object in Active Directory has an access control list. So as you're using PowerShell to search and update and otherwise manipulate Active Directory, you will be limited by the permissions on those objects in Active Directory. Now again, power is always a double-edged sword, so that means too that when our adversaries steal the credentials of IT people, and now they're searching Active Directory, maybe using tools like a Bloodhound, or they're trying to make malicious changes in Active Directory, then again, our hope is that these permissions will get in their way. Specifically, we're going to look at Active Directory permissions for delegation of authority and damage containment. So we don't want everyone in IT to be simply dumped into the domain admins group. We want to delegate at the OU level, organizational unit level, so that later if an OU admin account is compromised, and we assume that someday it will, then the hope is the harm is contained. All right, so that's what's coming up in today's manual. WMI, again, is the name of a service that you find installed and running on every Windows machine. It's been around since at least Windows NT Service Pack 4. The Windows Management Instrumentation service is Microsoft's implementation of some vendor-neutral standards. So there are vendor-neutral standards not proprietary to Microsoft named WebM and SIM. A big group of corporations got together to form a club. It's called the Distributed Management Task Force, the DMTF. It includes Microsoft and others. And this big group of vendors got together and they said, we need a vendor-neutral set of protocols and standards for doing remote monitoring and remote administration. The idea is that any device running any operating system, Linux, Windows, BSD, you name it, will be able to talk to any other device running any operating system using these standards and at least do some basic monitoring and perhaps a lot of administration. So WebM stands for Web-Based Enterprise Management, and SIM stands for Common Information Model. We use the WebM protocols to query the Common Information Model. Now, without diving into the deep end of all the acronyms, and for WMI and WebM and SIM, there's tons of acronyms. We're going to see them in just a little bit. The short of it is this. Think of the SIM standards as defining a virtual database that you can query with SQL. Now, your machine is not actually running SQL Server, but you could send queries that look like SQL queries, and you are searching a database that doesn't physically exist, but nonetheless, the queries still work. You can send a query and you get responses back. Don't worry, this will all be more clear in the next several slides. The WMI service is designed for IT people. It's like the all-powerful IT service. Earlier in this course, we ran PowerShell commands to view and manage networking settings. Virtually all of those commands use WMI to get their jobs done. So we love the WMI service and what it provides, but unfortunately, so do hackers and malware. Hackers love the WMI service. Hackers use the WMI service to do things like remote command execution and maintain persistence on our machines. So our goal here is to learn how to use PowerShell to interact with the WMI service, but also we're going to talk about securing access to the WMI service. And then later in the course, we're going to talk about security for PowerShell in general as well. There's lots of tools related to WMI. When PowerShell first came out, the main commandlet was named Get-WMI object. But this could only talk to remote machines using RPC. In other words, it really wasn't internet friendly. When PowerShell 3 came out, that include newer commandlets, that's what we're going to focus on, like Get-CimInstance. Now these can use RPC to talk to other boxes as well, but they can also use WSMan, Web Services for Management. Hey, that should ring a bell. That's what we saw in the prior manual. That's the protocol that we use for PowerShell remoting. And that's the protocol that can be TLS encrypted. So imagine, you can access a remote machine, PowerShell remoting, uploading and downloading files, and talking to the WMI service, all over a TLS encrypted channel. So is the WMI service, is it designed to be accessed over the internet? Yes. Because we can use the WSMan protocol, certificate authentication, and TLS encryption. There's many tools related to WMI. They're listed in your manual, but there's one tool in particular that is great. When you are first learning WMI, this is a wonderful, free graphical tool. This tool doesn't have to be installed. It's just a single binary executable program. And you can see in the bottom left-hand corner of the slide the path to that program. Please launch the WMI Explorer tool right now. So inside of PowerShell, it's in Sans, Tools, WMI Explorer folder, and the name of the program is wmiexplorer.exe. This is a great, free, graphical tool for interacting with the WMI service on your local box, but also remote machines. And it helps us to navigate in a graphical friendly way all of the acronyms and abstractions that we have with WMI. I'm going to launch that tool on my machine as well. So again, you can find this in the Sans, Tools, WMI Explorer folder, and the name of the program is wmiexplorer.exe. So please launch that on your machine. Now I'm going to expand it to full screen. In the upper left-hand corner, there's the computer field. It might appear to be blank, but in fact there's a single period. And in WMI speak, a single period is an alias for localhost. So click on the Connect button to connect to the WMI service on your own machine. All the information that you access through WMI is organized into namespaces. Now I know that the path says whack whack controller whack root. That looks like a shared folder, but it's not. You don't have a shared folder named root. These are called namespaces. They don't really physically exist in the same sense that DNS domains don't physically exist. It's just a naming hierarchy. If you want to visualize this as a shared folder with a bunch of subdirectories, that's perfectly fine to think of it that way, but that's just an analogy. That's not how it is physically implemented. The most important of these namespaces is SIMv2, Common Information Model, version 2. Please double-click on the SIMv2 namespace. Now, when you double-click it, at the very bottom left, it says Enumerating Classes. And after a few seconds, in the middle of your screen, you'll see the Classes tab, and you'll see all the classes inside of the SIMv2 namespace. Notice that there's over 400 classes here. Now, earlier in the course, we talked about classes in the .NET framework, or maybe classes in the schema of Active Directory. But this is a different sense of the word class. This is the word class like when we talk about the middle class. So the middle class is not like a blueprint for creating a person. The middle class is a set of people. And that's the sense of class that's being used here. It's a set of 0, 1, or more objects. If you want to think of a class as a table, I think that's a good analogy. So a class is like a table or an Excel spreadsheet. It might be empty. It might have one item or thousands of items. As you scroll through the list of the names of your classes, the names give a hint about what you find inside of it. Like, for example, we see things like Win32 battery, Win32 BIOS, cache memory, CD-ROM, and so on. If you scroll down just a little bit, you'll see a class named Win32 BIOS. Please double-click that. When you double-click a class, it's like searching that table. Now, what do you find inside of a class, or what do you find inside of a table? You find instances of that class. But if you want to think of these as like records in the table, that's a good analogy. Or in PowerShell speak, we would call these things objects. Now in the graphical interface off to the right, you'll see a tab named Instances. In this case, the Win32 BIOS class on my machine has one instance of the class, or if you wish, one record or one object inside that class. Now when I select and highlight that instance, notice that off to the right-hand side, it shows all the properties of that object and the data inside those properties. Very often, but not always, when you select one of these properties, then down below you'll get a short description of what that property is for. So that's the big idea. There's tons of information that you can access through WMI. First, that information is organized into namespaces on the left-hand side. Inside of a namespace, you'll find 0 or more classes. Inside of a class, you'll find 0 or more instances. And each instance is kind of like an object with properties and methods. Notice that down below at the bottom, it shows you the SQL-looking query being executed to gather the data being displayed. Now this is very handy because in just a few minutes, we're going to run queries just like this using PowerShell. But instead of typing in this query by hand, I can just highlight it and then copy it to the clipboard. I can then paste that into my PowerShell script. Here's something else that's nice about this tool. Off to the right-hand side in the middle, please go to the Script tab. So this is off to the right-hand side in the middle of the screen, the Script tab. And now click on the PowerShell button. The tool will generate some boilerplate PowerShell code. If you click the Run Script button now off to the right-hand side, click Run Script, it'll open up Windows PowerShell and execute the code. You can now see the output. And of course, if I close that shell and I go back to WMI Explorer, I can highlight that PowerShell code that was generated and I can copy that to the clipboard and paste that into my own script as well. So this is a wonderful free graphical tool for getting our feet wet with PowerShell, but also it'll help us to troubleshoot our PowerShell scripts, browse through all the namespaces and classes, and even generate a little bit of code. If you do a search on the name of a class, almost always the first link you get will take you to Microsoft's website with the documentation on that class, like the Win32 BIOS class. The documentation will list all the properties and methods, have links to similar classes, and very often you'll have some sample source code, usually in C#, but C# is similar enough to PowerShell that you can use it at least for rough guidance. Of course, if you want to see some actual PowerShell code for that class, do a search on the name of the class again along with the word PowerShell, and very, very often you will find somebody out there in the world with a blog or an article, something, where they have written a PowerShell script that queries or uses this class. And that's because this is one of the most popular things to do with PowerShell, is to use WMI. So you can look at other people's code and then use it as guidance. And very often there'll be a discussion about issues and bugs or other things that you have to work around, right? And it's really nice that somebody else has, suffered and that they posted this to the internet. So that way you don't have to suffer like that yourself. But there is tons of documentation and example code out there on Microsoft's website and on all the blogs and forums all around the world. Again, this is one of the most popular things to do in PowerShell. There's entire books written on PowerShell for WMI. So a class is kind of like a table. And you can search these classes with queries that look like SQL queries, structured query language. Now, technically, it's not SQL, it's WMI query language, it's WQL, but it's very, very similar in syntax to SQL. So hopefully you have some prior database experience that'll make it more clear. But the syntax is not that bad. Each item in blue in the slide is a keyword. It does not have to be capitalized. I have it capitalized here just to make it look nice. But the idea is that you will select one or more properties from a class. In this case, we are treating the class just like a table. And if you wanted to select all the properties, it would be select star and asterisk. And you can use the where clause to filter what you get back. So you could select one or more properties from a class, but where some property equals something, or is less than something, or greater than something, or like something. What's the syntax for these WQ queries? In your manual, this is on page 20, you have a table showing the special symbols, comparison operators, and syntax for WQL queries. Now you are more than welcome to memorize this table and type in your queries from scratch if you want to, but it's a lot more fun to simply use the WMI Explorer graphical tool, double-click on things, and then down at the bottom, highlight and copy that query to the clipboard. That is a lot more fun. It's also more fun to find other people's queries on the internet, and then you can copy and paste it, right? Assuming that it doesn't do anything malicious, copy and paste that from that web page into your own script. In this case, we're just copying the query, not the entire script. Now, how do we execute this query in PowerShell? The main PowerShell commandlet is Get-CimInstance. And as you can see, it has a query parameter where you pass in the query inside quotes. The keywords are capitalized in these examples, but it's not case sensitive. You can type this all in lowercase and it still works just fine. In fact, for the lab, on your machine, please run these queries that you see in the slide. In your manual, this is on page 21, and the lab is to simply run the queries. Notice that these queries are all more or less identical except for the class name. So after you type in the first query and run it, well, then you can hit the up arrow on your keyboard, hit up arrow, and then you can edit the prior query. And usually you just have to edit the very last word. So page 21 in your manual, please run these queries on your box. As you're running the queries, you're outputting objects with properties and methods. And that means you can pipe these objects into other commands like getMember, outGridView, or selectObject. But you may have noticed something strange. When you're using the graphical WMI Explorer tool, you can click an instance, and on the right-hand side, you see all of the properties. But here inside the command shell, you're running a query, and you might only see, like, for example, 4 or 5 properties. Where'd all the other properties go? Well, years ago, Microsoft was concerned that WMI would be overwhelming, and they didn't want to turn people off of PowerShell or off of WMI by showing, tens or hundreds of pages of output that perhaps would be incomprehensible. So, for good or ill, Microsoft kind of holds our hand like a babysitter, and by default, when you're running these queries, the objects that are outputted, PowerShell only shows you some of the properties. Now, at the very bottom of the slide, this is the last command. Notice that the output of the command is being piped to select star. Select is the alias for select object. And when you pipe it into select star, that's our way of telling PowerShell, hey, don't hold my hand like a babysitter, I can take it. Show me all of the properties and all the data. So for example, if I run a query, select star from Win32 computer system, notice that it's only showing a few properties. But if I run that exact same query and I pipe it into select star, well now on the left-hand side, I see the names of all the properties, and on the right-hand side, the data inside those properties. In other words, what we see in PowerShell matches what we see in the WMI Explorer graphical tool. So you just have to remember that if you're working inside of PowerShell and you want to display all these property names, you're going to have to pipe it through select star. Now, on the other hand, if I'm capturing the output of this command to a variable, and that's what you'll typically do in your scripts, you don't have to pipe it through select star. In this case, the objects with all of their properties and methods are inside the X variable. So, for example, I can go to any of the properties by name by typing in the variable a period, and then I get that graphical pop-up menu, the IntelliSense menu, showing me all the properties and methods. Now I can access, for example, admin password status. Well, what in the world is that? Admin password status, that property has a code number as its value. That's why it's really handy to do an internet search on the name of the class. Because very often the properties will have code numbers as their values, and you're going to have to research a table of all the code numbers and what the code numbers mean. But this is easy to research. Just do a search on the name of the class, that'll take you to Microsoft's website, and almost always they'll have a little table of the code numbers and what each of the code numbers means. So for example, admin password status might indicate that the administrator account is enabled and does not have a blank password. But there's no way you could have known that off the top of your head. So just be aware, a class may contain 0, 1, or more instances. Each instance could have many properties and methods, but there's no way you could know off the top of your head what these properties and methods do or what they mean. So very often you're going to have to do a little bit of Googling on the class name, maybe along with the word PowerShell, to look for some examples. All right, so don't feel bad if you don't have this memorized. Nobody has it memorized. The WMI service is designed to be accessed over the network. You can access the WMI service directly over an RPC connection, but you can also use the WSMAN protocol, the same protocol as PowerShell remoting, to talk to the service. And notice the port numbers that it uses, TCP 5985 and 5986, just like PowerShell remoting. So you could have one port number opened up to the internet, 5986 for example, require certificate authentication and require TLS encryption, and now we could do remote command execution, upload and download files, and also talk to the WMI service. How could we use this in real life? Well, for example, let's imagine that the firmware in your motherboards contains a tiny web server. And in fact, it probably does. It's called the Intel Management Engine. So that means for patch management, we're not just patching Windows and Firefox and all of our apps. Patch management includes patching the firmware in our motherboards. So, surprise, surprise, that little web server has a flaw that's exploitable. And now the challenge is, we need to query 10,000 machines and get the manufacturer of the firmware and the version of the firmware on all 10,000 boxes. We need to get that information to figure out which machines have recent firmware where the vulnerability has been addressed, or older firmware, and now we have to flash or upgrade the firmware on the machine to patch it to get rid of the flaw. So we can see at the top our query, select everything from the Win32 BIOS class. Now I have a computer list.txt file with a list of 10,000 computer names. I got that from Active Directory. In fact, later on in this manual, we're going to see exactly how we can query Active Directory to get that list. Technically, I don't even have to save the list to a text file. I could just directly query a domain controller and get an array of my 10,000 computer objects. But to get started here, it's a text file that's 10,000 lines long, a computer name on every line. As we talked about earlier this week, when you run get content and you get the contents of a text file, each line is piped into the next command. And in this case, we're piping it into for each. And recall from a few days ago that anything you pipe into for each goes into the cattransmit variable, $_. So what are we doing? For each computer name, we query that remote machine. So we're passing in the query in this case as a variable, and we're passing in the computer name as an argument to the computer name parameter. Now the output of that command is being piped. The output of that command is an object that represents the firmware, the BIOS, on that remote machine. That object is being piped into select because the only properties I care about are the name of the remote computer, the manufacturer of the BIOS, and the version of the BIOS. All the other properties I don't want. Now what comes out the backside there is an object with just those three properties, nothing else. And we pipe that object to export CSV. We're going to append those three properties to this comma delimited text file. Now it's very important here that we use the word append, the switch append, because after we append the BIOS information on the first machine, notice the squirrely brace here, we go back up to for each, and then we connect to the next machine in the list. So we're going to attempt to query 10,000 boxes and get the name, manufacturer, and version of the BIOS on all 10,000 machines and append that to one big comma delimited file. So you get that going, you go to lunch, you come back, maybe you're done, maybe you have to wait till the end of the day. It could take hours for this, but it's just going to keep on cranking through. And it's going to append the data to the end of the text file with every loop. So just in case it crashes, well, you still have your progress. You still have the CSV text file, and you can see where you left off. Now that you have a list of the firmware in all your boxes, now you can query that CSV file like in an Excel spreadsheet or grep or something like that, and you can extract the names of all the machines that now, unfortunately, you might have to hike around and physically touch to upgrade the firmware. But at least we have that information. Now this script really is like a boilerplate or skeleton script. It's a pattern that we can modify to query basically anything. For example, could I change the query to query a different class other than Win32 BIOS? Yeah, definitely. And could I pass in a different list of computers instead of, let's say, a list of every computer in the domain? Certainly could. And could I modify the names of the properties that I'm saving to the CSV file? Yeah, definitely. And finally, you could modify the name of the CSV file that we're saving the data to. So starting out with this basic script then, we could edit it and query more or less any class from any list of machines, save any properties that we want to a comma delimited file. On your machine, please go to the next lab. Now in this lab, we're going to query for the membership of local groups. And we're doing this through WMI. How are we getting our name, our list of computers to query? We're going to query Active Directory. And now we're going to export that information to an XML file. So this gives us a taste of some of the Active Directory scripting coming up this afternoon as well. So please turn to page 25 in your manual, page 25. So in the lab, you are querying the membership of a local group on every server and workstation joined to the domain. Knowing who is in the local administrators group is really important from a security perspective. We want to remove everyone from the local administrators group who should not be in there. So if you're an auditor, incident responder, a threat hunter, imagine all the information that you can gather through WMI this way. This is just one example, local group membership. Remember that in the SIMV2 namespace, there are over 400 classes of information. So there's over 400 classes. What are some of the other things that we can query? Well, how about searching event logs? In your manual, take a look at page 27. So here's a function for searching the security event log on a remote machine, and it only outputs events that indicate logon failures. So for the function getLogonFailures, you pass in the name of the remote machine. It'll give a query to the WMI service at the remote box, and it's the WMI service that does all the hard work, the heavy lifting of searching through the security event log, finding the events that indicate logon failures, and it sends you only those events. So very importantly, if the security log is like a 10 gigabyte size log file, what we are not doing is downloading that 10 gig of data and then searching it locally. Instead, we give the query to the WMI service on the remote machine, and it does all the hard work. It might then send you only a few megabytes of data, the matching data. So we can see in the middle, we're querying the Win32 NT log event class, but where, and then we have a filter, where the log file equals security, and the event code is 529 or 4625. Notice that the where filter can use Boolean operators and an or, and parentheses to group these portions of the test together. That means we could come up with a very precise filter so that when we query a remote machine, instead of getting back, hundreds of megabytes or gigabytes of data, we could have a very precise filter and get back just what we want and nothing else. Now, how to write these queries? Again, I recommend starting out with the graphical WMI Explorer tool to start clicking on things, and you can then copy the query out of that graphical tool into your script and then modify that. So you're more than welcome, of course, to type in and edit these queries by hand, but when you're first starting out, the syntax can be a little bit weird. So in this case, as you can see in the function, we store our query in a variable, and then down at the bottom, we pass in our query, and we pass in the name of the remote machine. The name of the machine was passed in as an argument to the function. The output of that query is a stream of objects that represent event log messages. These are event log objects. And event log objects will have properties like the name of the machine, the name of the log, the event ID number, date and time, and so on. Now, recall from just a couple slides ago, we had some boilerplate script. This line in the script, that could be replaced by a call to the function. Because whether you run Get-CimInstance directly, as here in the script, in the slide, or if you call a function that runs that command, the output is the same. The output is the same kind of sim object with properties and methods. So that means we could take this boilerplate script and then modify it so that we would call one or more functions, not just one, but possibly multiple functions for every computer name in the list. So in this case is a function for searching the event logs to find logon failures. Now the function in the slide is searching for logon failures. But very often what people want, like the incident responders, the forensics people, the threat hunters, very often what they want are the successful logons. So imagine that somebody comes to you and says, we need a list of all of the machines that Alice or Bob has logged on to in the last 3 days. And you say, well, log on how? Over the network or physically sitting at the console? And they say all logons or maybe just network logons. Now, if you had to manually use the graphical event viewer to dig through the logs of 10,000 machines, looking for and filtering for the last known logons, or let's say the logons within the last 3 days of Alice and Bob, it would take forever. And imagine you have no SIM. You're not forwarding this kind of log data to a central searchable database. But on the other hand, we could do this with PowerShell. So in this lab, you're going to run a script called getSuccessfulLogon. And this script, as you can tell from the name, uses WMI to search the security event logs on remote machines, but in this case looking for successful logons. And we get to control what type of logon it is, whether it's at the console, over the network, remote desktop services, and so on. All right, so please turn to page 30 in your manual, page 30 for the lab. At the end of the lab, there's a table which lists all the different logon types in Windows and the associated code number. You'll see these code numbers in the event logs, and oftentimes when you're reading articles or books about Windows security, they'll actually refer to the logon type by the code number. So they might say that someone mapped a drive letter and that was a type 3 logon. That means that was an over-the-network logon. It also implies they were exercising the network logon right. So the table there is mainly for reference. You can also filter the output of the script based on the logon type. So if you're only interested in, let's say, network logons or console logons or scheduled task logons, you can extract just what you're looking for. Now, stepping back for a second, let's think about a bigger use of all of this. So we've been running some queries, like, for example, querying the membership of the local administrators group and querying the event logs. But these are just, particular examples. There are hundreds of classes that we can query through WMI. Now, when you play on the blue team, it's like an information war. We have to gather mountains of data about all of the machines in our domain to look for the needles in a haystack, to look for those indicators of compromise. Now, the best way to get information from a computer is to have a full binary image of the drive and a full binary image of RAM. And now you can load those binary images into forensics tools. Now, yes, that might be like the gold standard for getting the most accurate data, but it doesn't scale. I mean, you can't make a disk image and a RAM image of every server and workstation every single night of the year, 365 days a year. It just doesn't scale. It's just not possible. But it doesn't mean that we can't gather tons of data. So while the gold standard might be disk and RAM images, full binary images, we can still gather tons of data and save that data as text files. So a snapshot is a set of text files that records the current operational state of a machine. It's all of the information that the troubleshooters, incident responders, forensics people, and in general, all the blue teamers need to secure the network. Now, of course, it could also be used for reconnaissance. It could be used by the red team. The red team, the penetration testers, the hackers, they also want to gather tons of information about our environment. It helps them to plan out their attacks, maintain persistence. Now, what's in a snapshot? A snapshot is a folder with a bunch of text files, and these text files, again, just include anything that would be useful to the blue team or maybe to the red team too. So processes, drivers, file system hashes. How about dump the entire registry to a bunch of big text files? How about timestamps on files, the entire event logs, and so on? Now, once you have a snapshot of a machine, you have a set of text files, you can now make another snapshot, let's say a week later, and then compare the before and after snapshot files. So we have a baseline of comparison plus the current snapshot. We can now extract the differences and find out what has changed. So for incident responders, right, or the threat hunters, they want to know what has changed in the last 24 hours or week or month or year. Comparing these text files is relatively easy. There's both graphical and command line tools that can compare text files and then highlight, like with different colors, highlight the differences between them. So whether you're playing on the blue team or the red team, everybody is trying to gather, like a vacuum cleaner, mountains of reconnaissance data. Well, of course, we call it reconnaissance when you're on the red team. When you're playing on the blue team, right? Well, then, is there a term for this? I would call it doing your job, right? How do you secure a network if you don't know what you have? The next lab, we're going to run a command, and that command can take a long time to run. So what we'll do is, please turn to page 37 in your book. You're going to run a script named snapshot. And that's going to create a folder and fill that folder with a bunch of text files that record the operational state of your machine. Now that script can take several minutes to run depending on how fast your computer is. By the way, if you scroll down about halfway inside the snapshot script to look at the commands producing the data, I think you might be surprised at how simple it is. Almost every command in the snapshot script is just a single line command where the output is being piped either directly into a text file or into a little function in the script that converts to a text file. The idea is that if there is more information that you want to gather as a part of the snapshot, it'll be easy to add more commands. Really, the only requirement is that whatever command you run, that the output be saved to a text file that we can use for comparisons. Now this lab then, the snapshot script, is just to give a taste of the broader possibilities. So when hackers or red teamers or penetration testers are doing a reconnaissance, they might steal some admin credentials and then they want to suck up like a vacuum cleaner vast information about the target environment. So they may have already broken in, but they want to maintain persistence for months or years. And to do this, they have to have a really good inventory. And the same thing for the defenders. It's hard to defend when you don't know what you have. So in this case, just doing port scanning, that's not good enough. That just gives you IP addresses, ports, MAC addresses, that sort of thing. But we want to go far beyond that. Early in the course, we ran getProcess. That outputs objects representing processes on a machine. Well, we can get information about processes from remote machines too by talking to the WMI service. So in the slide, you can see a query. Select star from Win32 process. Same thing for device drivers. There's a class for that, Win32 system driver, and that'll return objects about the drivers, even if the drivers are not currently loaded or running. Now let's imagine that we query the processes on a remote machine and we find an unwanted process, maybe ransomware, spyware, a hack tool, some unwanted process. Well, the process object that we got back will include the process ID number. And that's important because take a look at the bottom of the slide. I can now do a revise query. Select star from Win32 process where the process ID number equals X. Now we know what that unwanted process ID number is because we just queried all the processes on the remote machine. Now what's returned by this query is one process object. How can we remotely terminate an unwanted process? Well, with WMI, you can also invoke methods, execute commands, and there's a commandlet for this. You can see it at the bottom of the slide, invoke sim method. So the input object is that one process on the remote machine, and the name of the method is terminate. So we send that to the WMI service on the remote box, and the WMI service on our behalf now invokes the terminate method to kill the process. So talking to WMI service is not just for gathering data. In many cases, we can also make changes, in this case, terminating unwanted processes. Well, not only can we terminate processes, we can also launch processes. In other words, we can use WMI for remote command execution. With the remote execute function, you give the name of the remote machine and the command line, including any arguments that you want, used to create the process. As we talked about earlier this week, there's a special type of an array called a hash table. And hash tables are created with the @ symbol and a squirrely brace, not an @ symbol parenthesis. And each item in a hash table is a pairing. So to the left of the equal sign is the key, to the right is the value. And in this case, we're using the splatting technique. So command line, that's the name of a parameter, and command line, well, that's an argument being passed into the function. And now notice, we're using invoke sim method again. We pass in the name of the remote machine, and now I give it the name of a class. The Win32 process class, it has its own properties and methods. Now it might seem strange, but the Win32 process class represents the set of all possible processes, not just existing processes, but also all possible processes. Now I know this is pretty weird. I don't know if you took maybe computer science back in college and you studied a bit of logic and set theory. So in this case, Win32 process, you can think of as the set of all possible processes. So we have our existing processes, those already exist, but to bring a new process into existence, you have to call the create method. Now, the interesting thing here is that the create method is a method of the class as a whole. Normally, we talk about the properties and methods of instances of a class, but actually, classes have their own properties and methods too. So, we invoke the create method on the process class, and using the splatting technique, we pass in our hash table of parameters and arguments. In this case, it's just the command line that we want executed. Now, the WMI service on the remote machine impersonates us and launches the process as us, as our user account that we are using to authenticate to the machine. So if you authenticated as Alice or Bob, then the process is created with that account on the remote machine. This is one of the main reasons that hackers love the WMI service. The WMI service can be used for remote command execution. And notice how simple it is. The call that we make here, this whole little function is only 2 lines long, and technically, we didn't even have to use the hash table for the splatting. I'm just using the splatting here in the slide because I wanted a reminder of the technique. So technically, you could do this in 1 line of code. Let's do a comparison contrast of remote command execution with WMI versus PowerShell. So this is on page 43 in your book. So with WMI, the WMI service is installed everywhere and enabled by default. The target machine does not need PowerShell at all. Now, on the downside, when you're using WMI for remote command execution, you don't get an interactive command prompt with the remote machine. You don't get a session. You execute the command and you hope. You have to hope because there's no automatic return of the output back over the network back to you. The way hackers do it, they remotely execute a command, they redirect the output of that command to a file, and then they grab the file. That's how they can give the illusion that you have like an interactive command shell or that the output is being returned back to you automatically, but it's not returned automatically. You have to do some other tricks to grab the output. There's also a lack of management bells and whistles related to this feature. Now, WMI as a whole has lots of management bells and whistles, but specifically for remote command execution, not much. Again, WMI as a whole is being actively developed and maintained by Microsoft, but specifically for remote command execution, again, really not much. In fact, this has not changed as far as I know in over 10 years. This is not the standard or recommended way of doing remote command execution. The recommended way of doing it is PowerShell remoting. Now again, as we know, there are some negatives with PowerShell remoting, like PowerShell is not installed everywhere. For example, on the old dead operating systems like Windows XP, it's not installed by default. And even when PowerShell is installed by default, like on Windows 7, then the remoting is not enabled by default. So PowerShell remoting is enabled on SIR 2012 and later, not earlier versions, and PowerShell remoting is not enabled on any client operating system, not even the most recent version of Windows 10. And for the most part, both the source and target machines require PowerShell. I know that technically that's not true. You could use like a Python script to talk to the WinRM service on a remote machine. But if you want all the bells and whistles and you want to make it work nice, then effectively you have to have PowerShell. On the good side though, if you want an interactive command shell on the remote machine, there's built-in support for that. You can use enter PS session. And if you're using the invoke command, well then the output of that command is automatically sent back over the network back to you. It's easy to capture it. PowerShell remoting also has rich management capabilities like GIA endpoints, those sandboxes, transcription logging we're going to talk about later on this week. You can manage things like execution policies through group policy, and in general, we have lots of management hooks that we can get our fingers into. PowerShell remoting is being actively developed by Microsoft For example, with PowerShell Core and its integration with SSH. So, remoting is the standard recommended way of doing remote command execution. And I couldn't fit it on the slide, but PowerShell remoting is also recommended over the psexec tool. psexec.exe is very popular, but it's also widely abused by hackers and malware. In fact, the better thing to do is to forbid the use of psexec and forbid the use of WMI for remote command execution. So that now when hackers and malware use WMI for remote command execution, or when they use the psexec tool, that's an indicator of compromise. We know that at a minimum it's unauthorized, but also maybe we have caught hackers or malware in the act. Everyone in IT should only use PowerShell remoting for remote command execution. Is WMI being phased out in favor of PowerShell.net, or does Microsoft plan on maintaining this long term? WMI is going to be around for a long time because WMI is not just for PowerShell. Many of our graphical and command line tools are secretly using WMI in the background. For example, if you have a graphical tool that you use to inventory the hardware and software on the machines in your environment, I would say almost certainly it's using WMI to some extent in the background. So WMI is not going away. There's just too much that depends on it. Now, WMI over the internet, on the other hand, well, now that is pretty much just PowerShell. Offhand, I don't know of, let me think. I don't know of any third-party tools actually that access WMI directly over the internet unless they're using the WSMAN protocol, right? PowerShell remoting protocol. All right, so WMI is not going away anytime soon. And just as an example, in the next module, when we talk about managing local users and local groups, virtually all of those commandlets are secretly using WMI in the background. Here's another example of using WMI. The function is invoke, reboot, shutdown, log off. So the name of the function, right, gives a hint about what it's for. You give the name of the remote machine and the name of the action that you want performed. We saw a couple of days ago the switch flow control keyword. And I wanted to show how you can use a regular expression pattern with switch, because this is a very handy thing to do. So you can see in the slide then, we have the switch keyword followed by -regex, and then in something inside parentheses. Now, whatever is inside the parentheses is compared against the regular expression patterns that follow. So log off, shutdown, and reboot, those strings are regular expression patterns. They're very simple regular expression patterns, but nonetheless, they are legal patterns. So the idea is that whatever's inside the action variable, that's going to be compared against each of these regex patterns. And if the regex pattern matches, then you execute the following block of code. So for example, for the action parameter, if you pass in as the argument the word log off, well, that's going to match this regex pattern, and then we execute the immediately following block of code. This is something you'll do very often in PowerShell. You might read a textual log file, for example, and then compare every line of that log file against dozens of regular expression patterns. So we could use the switch flow control keyword like this, and nicely and conveniently read each line out of the log file, have a list of dozens of regular expression patterns, and for every matching pattern we could execute some code. Now in this case, what code are we executing? Well, notice that we are replacing the contents of the action variable with a code number. And why? Because we have to. Because we're about to call a function, and that function requires us to pass in a code number, not the name of the action. But we want to make this a friendly function, so we have the action parameter where you can pass in the name of the action that you want, like shutdown or reboot, and you don't have to memorize the code numbers. But when you actually call the function, you have to use the code number. All right, what's our query then? Well, in the middle we have select star from Win32 operating system, where primary equals true. What in the world is that? There's no way you could know this off the top of your head. This is another example of where you need to search on the name of the class, look at Microsoft's documentation, and what we see is that on a dual boot computer, the primary operating system is the running operating system. So what that query returns is an object that represents the running operating system. You'll get one object back from that query. Now, on the next line after that, we're going to use the splatting technique, so I need a hash table of parameters and arguments. Remember that if you have multiple items in a hash table, you separate each item by a semicolon. Now, here's something new that we haven't seen. Notice that the action is being cast to a 32-bit integer. int32 is the name of a class in the .NET framework. And when you put the name of a class in square brackets in front of a variable, you are converting the data in that variable to match that class type. So in other words, whatever type of number is inside the action variable is going to be converted, or as we say, cast to a 32-bit integer. Now, if it were to say int64, that would cast it to a 64-bit integer. Or if it were to say uint32, that would be an unsigned 32-bit integer. All right, so this technique is called casting, where you put the name of a class inside square brackets in front of a variable, and that tells PowerShell to treat the data inside that variable or to convert that data to that class type. So in this case, we're confirming that the number inside the action variable is a 32-bit integer. And then notice that we also have a second argument. It's just 0, but it's at 0, 16-bit, 32-bit, 64-bit. As you can see, we are casting that to be a 32-bit integer. Now you might wonder, why are we doing this? It's because we have to. We're about to call a function, and this function requires 2 arguments, and the arguments must each be a 32-bit integer. It has to be that exactly. How would you know this? You couldn't know this off the top of your head. The only way you could know this is by looking at the documentation on Microsoft's website or looking at somebody else's code on the internet. All right, so now we look down at the bottom. We're using invoke_sim method again. We're invoking a method on the object that represents the running operating system on the other machine. And the name of the method is Win32 shutdown. Then we pass in our arguments hash table for doing splatting. In other words, we're passing in our 2 32-bit integers. You might not be a C++ or Windows API developer. In fact, I'm guessing you're not. But we are calling a method Win32 shutdown, and that's the name of a method in the low-level programming interface to the kernel of the operating system. Well, this is kind of astounding, because we're using PowerShell, an uncompiled script, to talk to the WMI service, and on our behalf, the WMI service is calling this function in the kernel of the operating system. So on your machine, if you hit Control-Alt-Delete and then click on log off, shutdown, or reboot, that's actually the name of the function that's being called when you do it. So this is another reason why hackers love the WMI service. By talking to the WMI service, the service is able to call functions, not all of them, but many functions from the Windows API, namely from the programming interface for the kernel itself. So imagine that you use this function here, this PowerShell function on the slide, and you remotely execute the command to reboot the other machine. So there's the user busily working away, typing, using his or her mouse, and then all of a sudden, the user's applications close and the machine reboots, just as though the user had hit Control-Delete and then clicked on the reboot button, because in fact, it's the exact same function that's being called in the kernel. All right, so again, this is another reason that hackers love the WMI service. It gives relatively easy access to many of these useful functions in the kernel of the operating system. When hackers steal credentials, they'll need to use those credentials to authenticate to other boxes over the network. What if the credentials that they've stolen are for local accounts instead of domain accounts? Well, when you're logged on with a domain account, you can use single sign-on. When you talk to the WMI service on a remote machine, you'll typically use Kerberos. You're not prompted for a password, you simply log on. But when you're logging on with a local account at the target box, well, then you have to explicitly or manually authenticate. So, how do we do that? There's a built-in commandlet in PowerShell named Get-Credential. And when you run Get-Credential, you get a pop-up dialog box asking for a username and password. That's now saved to the creds variable. The password, by the way, is encrypted in memory. It's called a secure string. On the next line, we're running new sim session. We actually saw this earlier. We created a sim session for the sake of PowerShell remoting. But now I'm using that same command to create a session. Under the hood, it's actually the same thing that's going on. New sim session is actually specifically for WMI, but under the hood, it's the same protocol. My apologies. But it's the same idea. We run the command new sim session, we authenticate manually or explicitly with the creds, and we give the name of the remote machine. What we get back is a reusable session object. This is using the same protocol as PowerShell remoting, WSMan, and is talking to the same service, the WinRM service. The difference in this case is we have a reusable session for going through the WinRM service to talk to the WMI service. And now, our other sim commandlets can use that existing session. Again, by analogy with our PowerShell remoting commandlets, you create a reusable session, and for PowerShell remoting, we have enter PS session and invoke command, and they can use an existing session object. Well, the same thing goes for all of these sim commandlets, these WMI commandlets we've been talking about, like Get-CimInstance, invoke sim method, and here's a new commandlet that we haven't seen. It's called Get-CimClass. But notice that off to the right-hand side, just like the other sim commandlets, this one also can take an existing session instead of creating a new one. So over the last several slides, we've seen queries that follow a pattern of select star from a class. And we did that over and over again, select star from, select star from. Well, here's a shorter way of doing the exact same thing. If you do Get-CimClass, you simply give it the name of the class, and secretly in the background, it runs the query select star from that class. It's just a shorter way of doing that exact same query. The main thing to see here is how these sim WMI commandlets all support a session parameter that allows you to reuse the same session over and over again. So the slide demonstrates how to authenticate with a local account, or in general, how to authenticate explicitly or manually. Well, now that brings up the question. I'm worried that hackers have installed malware on my machines. They're running tools like Mimikatz, for example. Now, if I authenticate to a machine, I might accidentally expose my credentials to the malware running on that computer. I don't know which of my machines have been compromised. If I knew that a machine had been compromised and were running malware, well then I would scrub the machine's drive, right, and flash the firmware. So that's the problem. I don't know which machines are running malware. So when you have a choice, authenticate with a local admin account instead of a domain account. Domain accounts are specifically designed for single sign-on. Yes, they're more convenient, but they're also more dangerous because of that. Instead, if we have a local account, let's say it's named Tech49, then you could authenticate as that local account that's in the administrator's group. The password of that local account is not the same as any other local account on any other machine. So if my adversaries have malware just waiting for me, the malware might steal the password or the password hash or the security access token or any other credentials, but it won't really matter because the password of that local admin account is different than every other local admin in the domain. In fact, managing passwords like this, we have a lab on that coming up. Be aware that to log on to a machine this way, whatever account you use, either local account or domain account, it has to have the network logon right. Conversely, if I deny the network logon right to, let's say, local accounts, well then you won't be able to log on over the network at all with local accounts. You'll only be able to log on like when physically touching the keyboard of the machine. If you're not familiar with logon rights in general, that's fine. That's coming up later in the course. But I just wanted to mention that we are talking to the WMI service remotely, so we are exercising our network logon right to authenticate to that box and talk to the service. Now, when we authenticate to the other machine, there are some more options that we can choose from. There's a benefit here to explicitly or manually authenticating. We have access to these bells and whistles. So for example, there's a commandlet called new sim session option. And with the use SSL switch, we're setting a flag inside the option variable. Now, it says use SSL, but in fact it's going to be TLS. But to use TLS authentication and encryption, you have to have a TLS compatible certificate installed and then bound to the service. We haven't yet done the PKI manual. That's coming up later in the course. Later in the course, we're going to install certificate services. We will have a root certification authority, and we're going to deploy TLS certificates to all of our machines. But we're not quite there yet. But once I have that option, notice the second line. When I create a new sim session to another machine, I can pass in that option object. And that option object, you can see from the first line, specifies use SSL. Now I couldn't fit it onto the slide, but on the prior slide, you would also pass in credentials and the name of the remote computer. Because when we're creating a new sim session, you have to give the name of the remote machine. But we have some other options too. Notice that I can do new sim session. Here's another session option. I've got that option object that specifies use a certificate, but I have another switch, certificate thumbprint, but that's not the thumbprint of the TLS certificate off the target machine. That's the thumbprint of my certificate. So imagine that I have a smart card or a smart USB token like a YubiKey. Certificate thumbprint is the hash or thumbprint of my certificate on my smart card or my YubiKey. So that means with this combination of options, I'm authenticating the target machine with its TLS certificate, I'm TLS encrypting all the traffic, and I'm being authenticated not with the username and password and not with Kerberos, but with my certificate and private key. And preferably, where do I keep my certificate and private key? On my smart card or my smart token. So if you are going to do PowerShell remoting or WMI over the internet, it's highly recommended, it's basically mandatory, that you either use TLS or IPsec, and then for the authentication, we want to get away from single-factor password authentication. We want to use smart cards or smart tokens whenever possible. Down at the very bottom, we can see another parameter. It's the authentication parameter. And then we would choose one of the following arguments. This gives us explicit or manual control over the authentication protocol used. Now, if you are using a certificate, then you do not specify the authentication method. But if you're not using a certificate, then you could choose, for example, Kerberos. That works great inside the LAN for domain joined machines, but you can't use it on standalones. Basic authentication sends your password in plain text. So if you are using basic authentication, then using TLS encryption or IPsec encryption is pretty much mandatory. Cred SSP is interesting, but dangerous. Cred SSP will send a copy of your password to the remote machine, and at the remote machine, it will have a plain text copy of your password in memory. That means if the machine needs to impersonate you to access some third box on the LAN, well, it's got your plain text password, it can impersonate you, act as your agent, so to speak, and then access other machines inside the LAN. Now, yes, that can be convenient, but on the other hand, is the machine we are connecting to, is it malware infected? For all we know, that machine is running something like Mimikatz or other malware, and it's just continuously scraping out of RAM, like every 30 seconds, every credential it can find. So when you authenticate with Cred SSP, you want to encrypt all that traffic, like with TLS, But then after your password is sent over the network, it then goes into the memory of the target machine in plain text. And that's where malware can scrape it out of memory. Digest authentication does not send your password in plain text over the network. It's a hash of the password along with some other data. Digest is rarely used, however. Digest authentication is mostly associated with IIS, Microsoft's web server, when applications are specifically configured to use Digest. So Digest was popular, I would say maybe, 8 to 13 years ago. It was pretty popular for a while. It was certainly better than basic authentication, but it's mostly fallen out of disfavor. And finally, NTLM domain, of course, will let you use NTLM, like to a standalone machine. In your manual, it describes all the pros and cons, but this shows at least how we can get manual control over the identity that we're using to authenticate, whether to use a TLS encryption, the certificate on our smart card or smart token, or if, let's say, you're inside the LAN and you wanted to force the use of Kerberos, and to make sure that you're not using NTLM or any other method, well, there is a switch for that. There is an argument for that, Recall that all the information that you access when you go through the WMI service, all the information is organized into namespaces. Now, these namespaces, they're not physical folders on the drive. But nonetheless, these abstractions, these naming categories called namespaces, they have permissions. We need to add another snap-in to our MMC console in order to view the permissions. So please go back to your virtual machine. This morning we created a MMC console named Tools on the desktop. If you don't have that MMC console, or if you need to make a new one, it's easy to do. Just run mmc.exe. That'll make a new fresh MMC console, and then you can add back any snap-ins that you wish. So either open up the Tools MMC console you saved to your desktop, or please make a new one. Now in the console, please pull down the File menu, Add Remove Snap-in. File menu, Add Remove Snap-in. In your list of snap-ins, scroll down to the very bottom and you have a snap-in named WMI Control. Add the WMI Control snap-in to the right-hand side of the screen. Select Local Computer, Finish, and then OK. Don't forget to save the changes to your console, so pull down the File menu and select Save. That way when you come back later, this new snap-in will be there. Now, expand down the WMI Control snap-in, then right-click on the snap-in and go to Properties. So please right-click on the WMI Control snap-in and go to Properties. In the Properties of the snap-in, now please go to the Security tab. On the Security tab, you can expand down your list of namespaces. Child namespaces will inherit their permissions from their parent namespace. So if you modify the permissions on the root namespace at the very top, by default, those permissions will be inherited by all the child namespaces underneath. So please select the root namespace and then click on the Security button. We're now examining the permissions on the root namespace, which is probably inherited by all your child namespaces too. If you scroll down a little bit, you can see that one of your permissions is named Remote Enable. Now that's the permission you have to talk to the WMI service from over the network. Notice that authenticated users, that group does not have Remote Enable. But if you select the administrators group, if you highlight that group instead, the administrators group does have Remote Enable. So now the question comes up, who is permitted to talk to the WMI service over the network? Well, by default, it's only the administrators group. But let's imagine that an auditor calls up and says, I need to be added to the administrators group. Why? Because the auditor is running a bunch of audit tools that secretly use WMI in the background, And according to the documentation, the only way you can get around this problem is to add the auditor to the administrators group on thousands of boxes, which maybe you don't want to do. So the auditor is working on, let's say, like a six-week project. You could create a group name auditors, or if you wanted to, you could even add that auditor specifically by name. So I could click on Add, and for example, let's say the auditor's name is Amy. Now I could add Amy to the list. I grant the permission, Remote Enable, and then I also scroll up to the top and I explicitly deny the Execute Methods permission. So again, I've added just one user just as an example. You don't have to do this yourself, it's just an example. But I've added a user. I'm explicitly denying the Execute Methods permission. And then down below, I've added the Remote Enable permission. So that means Amy, or if I do this for an auditor's group, this auditor will be able to remotely talk to the WMI service, but the auditor will not be able to execute any methods. And that'll go a long way to preventing the auditor from making any changes. And especially, the auditor will not be able to use WMI for remote command execution. Because as we saw a couple slides ago, to launch processes through WMI, you have to invoke a method named create. But if you can't invoke or execute any methods whatsoever, well then, one of the many things you can't do is to launch processes this way. You might wonder, how can I manage these permissions across thousands of machines? And like everything else, it's scriptable in PowerShell. So you don't have to use this graphical tool. These permissions can be scripted just like share permissions and NTFS permissions. But it gets even better. Because the WMI service is so widely abused by hackers and malware, now please click on the Advanced button here at the bottom of the dialog box. Click on the Advanced button. Now we see not only do these namespaces have permissions, they also have audit settings. We can log all interactions with these namespaces. So on the Auditing tab, I can click on Add. At the top, I select a principal. The principal is the user, computer, or group whose activities I want to log. And again, since we're using Amy as the example here, I type in Amy again. In real life, you'd probably select a group, but this is just to keep it simple. Now, what kind of activities am I logging? Successful, failed, or all types of activities. And notice that audit settings can be inherited or not. For example, I could apply these audit settings to this namespace only, or to this namespace and all child namespaces too. Off to the right-hand side, I click Show Advanced, and now I can check the boxes for the activities that I want to log. And in particular, I'm especially worried about the execution of methods. So I'm explicitly denying Amy the execute method permission, but I also want to log even attempts to execute a method. So the method call should be blocked, but I want to log it anyway. All right, so all this is in your book. On this slide, it talks about permissions. And on the next one, it talks about the audit settings. This is all in your manual. No need to write it down. Now, when you enable auditing of WMI namespaces, you have to use the Other Object Access Events audit policy. So this is one of the what's called the advanced audit policies in Windows. That's the name of the audit policy that has to be enabled. And you have to configure the audit settings on the namespace itself. Don't worry, this can all be scripted in PowerShell. Now, once you have this auditing enabled, it writes to the security event log. And here we can see an example, event ID 4662. Notice off to the right-hand side in the screenshot, when you log interaction with a namespace, it also logs the WQL query. So we can see the query here. It says select star from Win32 process where name is like LSAS. Now this is a gold mine of information for the incident responders, threat hunters, forensics people. This is a goldmine, because hackers and malware so widely abuse WMI, and part of the reason that they love it is nobody enables WMI logging, because nobody knows even what WMI is for. So if you're an attacker then, being able to use WMI to do reconnaissance, gathering data, remotely executing commands, by default, it's not going to be logged because nobody turns on WMI logging. Nobody even knows about it. But if you enable this logging, then you can capture a goldmine of information for forensics, incident response, and threat hunting. Because now we can see what they're looking for. We can see the methods that they're calling, the command line arguments that are used. If you enable this, then prepare to be chased down the hallway at your building and have like forensics or threat hunting people chase you down, give you a hug and kiss you on the cheek. Because nobody knows about this. Nobody is enabling this logging. But this is golden. Learning WMI is useful for other things besides PowerShell. Many of our graphical administrative tools secretly use WMI in the background. Now, earlier we talked about group policy. Let's see how WMI relates to group policy. So you don't have to follow along on your machine. In fact, it's probably better if you just watch. I go to, the day 3 folder, sim subdirectory, and I've got a script here called WMI sample GPO filters. Now this is not really a script, it's just a bunch of WMI queries. So for example, here's a WMI query that returns true if your machine is Server 2019 Data Center Edition. Or scrolling down a little bit, you would like to know, is the machine a Dell Latitude laptop? Or does the machine have at least 16 gigs of RAM? Or scrolling down a little bit further, is it Sunday? Here's the query. Select star from Win32 local time where day of the week equals 0. Well, in WMI, each day of the week is assigned a number. So 0 for Sunday, 1 for Monday, and so on. So if I run this query and it returns, well, anything, that means it's Sunday. If it returns nothing, it means it's not Sunday, it's some other day of the week. Now, how can I use this? I'm going to copy this query to the clipboard, and I go back to the Group Policy Management snap-in. In Group Policy Management, I go down to WMI Filters. I now right-click on WMI Filters, New, and I'm going to create a filter called Only on Sundays. I click Add, and then paste in my query. Notice that you can add multiple queries here, but we've just got one. Now I save it as a WMI filter. If I now select a group policy object, I go to the Scope tab, and down at the very bottom, I can pull down the menu and select a WMI filter. This one, Only on Sundays. Now what happens? Well, the next time machines in my domain refresh group policy, they ask the domain controller, is there a WMI filter associated with the GPO? Yes, there is. So each computer will download that WMI query and run it locally. The WMI query does not run on the domain controller, it runs on each of the servers and workstations that are downloading the group policy objects. So imagine a laptop downloads the WMI query and runs it locally on the laptop, and it returns nothing. Remember, this is a query that will return something if it's Sunday and returns nothing if it's any other day of the week. And because that query returned nothing, the laptop will not download the associated group policy object. And because it doesn't download it, it doesn't apply it. But now, a few days later, group policy refreshes on that laptop. Now it's Sunday. So when group policy refreshes, it runs the query again. Now the query returns true. It outputs something. Well, now the laptop connects to the domain controller, downloads and applies the GPO. In other words, we now have a group policy object that is only applied on Sundays. This is another way that we can target group policy objects to our machines. So again, I go back to my to my list of WMI queries. Here's another one. You would like to know, is the machine in the Eastern time zone? So in this case, I copy the query. I go back to the Group Policy Management snap-in, down to WMI filters. I right-click, create a new WMI filter. I'll call it, here we go, only in Eastern time zone. Add, paste in my query. OK. Click on Save. Now I go back to my Group Policy object and notice that it appears on the menu of WMI filters. I can only select one filter at a time. So it's only on Sundays or only in the Eastern time zone. I've made a mistake. What I really meant to say was only on Sunday and in the Eastern time zone. That's easy to fix. I go back. There's the one that says only on Sundays. I double click. On the right-hand side, I click Edit Filter. Now we click Add, and I add that one that tests to see if you're in the Eastern time zone. Because now we have two queries in this filter, and I'm going to rename the filter only on Sundays in the Eastern time zone. Now the machine will run both of these queries, and it's only if both queries return true or return something at all will the associated GPO be downloaded. So now I go back, I select my Group Policy object, and notice it's already updated the name here. So that means this Group Policy object is only going to be downloaded by machines on Sunday if the machine is currently in the Eastern time zone. And we can keep on adding more and more WMI queries to that filter to make it a more precision guided group policy object. Here's another place we can use it. Remember earlier, we were creating scheduled tasks with group policy objects. So I'm going to edit a group policy object. I go to Computer Configuration, Preferences, Control Panel, and then down to Scheduled Tasks. This is what we did earlier. As we talked about before, these scheduled tasks are called GPO preferences, and because it's a preference item, that means it has a Common tab. And here in the Common tab, I go to Item Level Targeting, I click the Targeting button, and as we saw before, I can now pull down a menu of selection criteria that the machine has to match in order for that GPO preference setting, the scheduled task, to be applied to it. Notice what's at the bottom of the list. It's WMI query. When I select WMI query from the bottom of the list, I can now paste in my query here, and I can use that as one of my additional selection criteria. Because I can query almost any aspect of the machine through WMI, I can use almost any aspect of the machine for applying or not applying this GPO preference setting. In this case, the GPO preference setting happens to be for a scheduled task that runs a PowerShell script. And of course, you could add multiple WMI queries here. I just keep on adding more and more queries to the list. And between each of these queries, I could set it to and, or not. All right, so learning WMI is useful not just for PowerShell, but for other purposes too. And I bet you have third-party network management tools already in place, and secretly those tools are using WMI in the background. Windows Admin Center is a free web application for remote administration. So on the left-hand side in the slide is your laptop. You open up your browser, you establish a TLS encrypted channel to the Windows Admin Center gateway. Now you have a nice friendly graphical interface in your browser. And going through that gateway, you now use the WSMAN protocol, that same protocol for PowerShell remoting and also for WMI, to talk to your Windows 10 workstations and your Server 2012 later servers. For example, those servers could be server core, so they don't have a full graphical interface, but we can still manage them through a friendly graphical tool in our browser. So anywhere in the world, you could have your laptop, authenticate to the Admin Center gateway over a TLS channel, and then now you could access, how about your machines inside the LAN, in the DMZ, or how about in the cloud somewhere? Who knows, maybe the Windows Admin Center gateway is itself a virtual machine hosted by a cloud provider. Remember, the WSMAN protocol can be authenticated and encrypted with TLS. So no matter where those laptops or servers are on the right-hand side, inside the LAN, the DMZ, or up in the cloud somewhere, as long as you can establish that TLS channel to the machine, well, then you can go through the Admin Center gateway to manage it. So in the lab, you're going to run a script that'll run a bunch of other scripts to install the Windows Admin Center on your server core VM. And then we're going to go back, or you're going to go back in the lab, back to your controller VM, the one with the graphical interface. You'll launch Firefox and log on to the Windows Admin Center. All right, so please turn to page 72 for the lab, page 72.